Welcome to a video walkthrough of the air pollution simulation. This simulation allows students to explore the effects that different weather conditions and atmospheric pollution scenarios have on air quality within a given geographical setting. The simulation starts with an introduction and some user guidelines, which I will address along the way. Here we have the simulation window. The simulation runs within the CODAP data analysis software. I will show you how students can investigate the simulation output using some of the CODAP's graphing and analysis tools. The CODAP functions and menu can be found at the top of the browser window. In the image, we see a coastal city bordered by mountains. Cars and a power plant represent sources of pollution. We can control the number of pollution sources by adjusting the scroll bar for cars and power plants. One can also choose the amount of pollution produced by each car by increasing or decreasing car pollution, or by making a percentage of the cars electric. The pollution output of each power plant can be specified with the power plant pollution scroll bar. The scroll bars on the left represent weather in the form of wind, temperature, sunlight, and rain, each of which can be increased or decreased. The wind can also change direction. It can be either seaward or landward. Note that no actual values or units are attributed to these user-specified properties, so we can do assessments and make comparisons only in a relative sense. I would like to point out a few things while the simulation is running, so let's click on Start. The graph is a plot of air quality index, or AQI, of both primary pollutants and secondary pollutants as a function of time. The higher the AQI, the lower the air quality. Primary pollutant AQI is plotted in dark brown and secondary pollutant AQI in orange. Similarly, primary pollutants are represented by dark brown dots in the image, and secondary pollutants by orange dots. Rainfall is represented by blue dots. It should be noted that rainfall occurs at random times, but the frequency of rainfall events depends on the setting of the rain scroll bar. So increasing it causes rainfall events to happen more frequently. Rain is not always visible in the image, but rainfall events can be identified as sharp decreases in AQI on the graph. Yellow dots symbolize sunshine. Sunlight promotes the formation of secondary pollutants. So the secondary pollutant AQI increases with increased sunlight. As we would expect, higher temperatures are relatively effective at dispersing pollution. In this geographical scenario, lower temperatures and a landward breeze or sea breeze could cause an accumulation of pollution inland. To generate a table of the AQI time series seen in the graph, the simulation must first be stopped. Then click on Analyze Data. Expand the window to see the AQI data for the duration of the simulation. In the table on the right, we have tick values and concurrent primary pollutant AQI and secondary pollutant AQI. The table on the left contains numbers corresponding to the input specifications. Sometimes it's necessary to delete AQI data points from the table, such as with comparisons when different data sets need to be equal lengths. Left-click on the index number of a data point in the table on the right and select Delete Case. Data can be saved as a CSV file by clicking on the ruler and then on Export Case Data. Select Measurements to save the AQI time series on either Google Drive or one's computer. To import the data again at a later time, the CSV file icon can be dragged into the CodeApp workspace, which I will demonstrate shortly. Alternatively, the file can be opened in Excel. To clear the table, delete each data run by left-clicking on the index number in the left-hand table and selecting Delete Cases. Alternatively, one can reload the web page to clear the table. Just closing the table will not clear the datasets from previous runs. Let's see how we can investigate an atmospheric pollution scenario inspired by real-world conditions. Click on New Run. Now, let's assume that we have a highly populated city with a lot of industry, without strict regulations regarding car exhausts and smokestack emissions. The city is experiencing cool temperatures. It is sunny and dry and calm wind. The legend on the graph can be removed by clicking on Key. Air quality deteriorates relatively quickly. On the lowest rainfall setting, rainfall events are infrequent, but they cause short-lived improvements in air quality. It is important to run the simulation long enough to have sufficient data points for a meaningful data analysis later. I did a similar run of 1,000 ticks previously, so I can import that into the workspace to save time. I can now drag the previously saved CSV file from my desktop into the workspace. I will select Create a new dataset. And here we have the data table. First, I will plot a primary pollutant AQI time series. Click on Graph. To assign the horizontal and vertical axes, simply drag the headings of the desired variables into the title positions on a graph. So I'll drag ticks to the X-axis position and primary AQI to the Y-axis position. I can turn this into a line graph by clicking on the ruler and then connecting lines. We can create a scatter plot to test the correlation between primary pollutant AQI and secondary pollutant AQI. So I will place primary AQI on the X-axis, secondary AQI on the Y-axis. I can select the ruler and least squares line. This gives us a best line fit and its equation. Next, we can do a statistical analysis. Clicking on Graph, we can drag one of the variables into the X-axis position. Let's do primary AQI again. We can now find values of, for example, the mean or the standard deviation. And to see the values associated with these numbers, we can select Show Measure Labels. It's also possible to read data values off the graph by hovering over data points. One can group the data into air quality index categories, which may be compared to the AQI health standards of a chosen country. I'm going to create a graph again of primary AQI on the x-axis. I will click on the histogram and group into bins. Select % on the ruler icon to see how much time is spent in each category. We can also specify the bin width. I recommend that you save the workspace in order not to lose plotted graphs. This can be done from the Code App menu. Save in Google Drive, where subsequent saving will be automatic, or on one's computer. Other interesting ways that the simulation can be used is by changing the pollution properties while the simulation is running. This might be done, for example, to model the implementation of atmospheric pollution mitigation regulations when certain AQI thresholds are exceeded. The weather properties may also be changed during a run to model variability in atmospheric conditions. For example, one might want to investigate the effect of alternating strong sea breezes with weak land breezes. I hope that you found this video helpful and that the simulation will be of great value to you and your students. Thank you for watching.